We end this week by combining the abstraction that we studied during this week. So when we are writing algorithms, we'll do that in different models. The first model is what we call the fail-stop model. The fail-stop model combines crash-stop process model with the perfect or reliable links and the perfect failure detector P. If we are using this abstraction, we say that we are working in the fail-stop model. The fail-stop model assumes that we are in the synchronous model, and that's why we can use a perfect failure detector. Some of the algorithms will work on another model, which is the extreme in the spectrum. That model we call the fail-silent model. In the fail-silent model, we are still using the crash-stop process model. We are using perfect links. These are reliable links, but we have no access to a failure detector. This means that actually we are in the asynchronous system model. For the asynchronous system model, we have to write algorithms that do not rely on failure detectors. We will see that in the next lecture. Then we have the fail-noisy model. The fail-noisy model is a crash-stop process model, perfect links, but we are using the eventually perfect failure detector. So this model is the partially synchronous model. When we are writing algorithms in this model, the fail-noisy model, so our failure detector could be inaccurate, and we don't know when it's going to be accurate. Therefore, we have to make sure that whatever we do to guarantee our safety properties, we assume always that our failure detector is inaccurate. We'll discuss this issue in the next lecture. Then we have the fail recovery model. In the fail recovery model, we have crash recovery process model, and we also assume that we have a persistent store, that we can store critical information. Many algorithms will assume the stubborn links. In the rest of the course, we will always start writing algorithms for the simplest model, which is the crash-stop system with perfect failure detector. It's the fail-stop model. We give the algorithms, and then from then we go and try to make a weaker assumption and revisit the algorithm. So from there, we can move either to the fail-silent model, the fail recovery model, or the fail-noisy model.